system. We speak with customers on a daily basis on their desires or needs to install pit tag monitoring systems in rivers and fishways and hatcheries. And Rolf, who's presenting today, had this idea of putting together a presentation that kind of goes through the workflow or the thought process of how, I guess, what our options are for configuring antenna systems for the various applications. And that was the impetus for today's webinar. Before we get going, I have a couple of housekeeping items. As you can see, everyone is on, I'm supposed to turn on my video. Everyone is on mute during the presentation. If you want to ask questions, you can type them in the Q&A box or the chat box on the right-hand side of the screen, and I will interject those questions to Rolf as he goes along during his presentation. And we'll also be recording the webinar, and it'll be available on our webpage later this week. There's a news section in the ribbon on the top, and if you drill down through that, you'll be able to find this webinar as well as the other webinars we've hosted this year. And let me see. So finally, hope everyone is being safe. It's kind of a crazy time, this COVID pandemic. Safe and probably like you guys, working in a variety of working in an office or working at home. We're distributed in our different work locations and working safely, but also responding to customer inquiries and emails and phone calls as we can. So don't hesitate to continue to call us if you have questions. And with that, I'll turn it over to Rolf, and just a little bit of background. Rolf Byens is our project manager. He's located in Belgium, and he's been with us for about a year. And he works with Armando Piccinini, who is our sales lead in Europe, who's in Italy, as well as Christian in Norway. But Rolf's been assisting those guys and working on his own and helping the customers in Europe and the UK and Ireland on the design of their pit tag systems. So with that, I thanks again for joining us, and I'll turn it over to Rolf. Rolf, go ahead.
Thanks, Steve, for the introduction. Hi, everybody. Welcome to our webinar. As Steve mentioned, I'm working for Biomark now, and I used to work as a fisheries biologist in Belgium for more than 20 years. So during that period, I had the opportunity to work with different fish telemetry techniques, among which pit telemetry. So today we'll run through some theoretical issues that we have to understand. I know it's maybe not really fancy, but it's quite important to have a good understanding of those before showing you the whole Biomark range of in-river antenna designs. So what's the use of in-river pit antennas? I think like once your antennas are in place, you can keep on tagging fish fairly cheap and collecting data for many, many years. So regarding research topics, these are numerous, so I'll sum up just some of them. Of course, downstream, upstream migration of big migrating fish species is quite popular among the world. We can look at migration direction, the use of particular habitats, restored side channels, for instance. We can evaluate whether weirs or hydropower dams are fish migrating barriers or not. Sometimes there are fishways, but are they working properly, etc. Also a management for hydropower operation. If you can predict downstream run of a kind of species that is vulnerable for hydropower injury, habitat use, survival estimates of restocking, etc. So there are a lot of topics that can be looked at by using pit telemetry. First of all, let's talk about antenna detection efficiency. I know every single fish biologist dreams of having 100% detection efficiency. And to be honest, in many cases, this is the fact or nearly the fact. Also, this efficiency is not a fixed thing. It can be variable over time. By changing of the environment around the antenna, you can have power breaks. There are multiple reasons why this efficiency can change. Um, if the environment should change, we do have a great reader, our IS1001 reader, which we always use on our antennas, and that will auto-tune every time an antenna is slightly detuned. So to guarantee an optimal read range related to actual noise levels. So antenna detection efficiency is mainly determined by three variables. We here have river depth, the number of tags in your system, and of course your antenna read range. We will have a closer look at each of these ones. This one now. So first, the river depth. A wide river being very wide and shallow is no big issue to use pit telemetry, but a deep river is in theory not very suited to use a pit telemetry setup. Your detecting efficiency will be poor. Though we can propose some solutions to tackle deeper systems. We could think of selecting special places like bridges, water mills, hydropower plants, so man-made structures along the river where you can mount antennas more easily. Or we can think about using both surface and bottom area antennas to cover more water column. And another a different approach, but quite interesting, uh, you should consider to make a choice for a qualitative approach instead of a quantitative by only covering some specific spots or areas within your deeper river zone. This is feasible by using our submersible antennas or by only, for instance, scanning on benthic areas. Another maybe surprising variable that can influence your antenna efficiency is the number of fish that you tagged, so the number of tags in your system. There is a direct relationship between detection efficiency and the number of tags in our system. I'll show you a graph. So on this figure, you can see the relationship between antenna efficiency, the x-axis, so 100% efficient detection, and the bias of your result. In other words, the underestimation of the detected fish. So first, mind the colors at your right. All blue dots are projects with 1,000 fish tagged. Of course, it's a simulated graph. As red or orange dots are projects with a small amount of fish, like 10 or 20. We can see clear now that even with the low detection efficiency, like in here, tagging a lot of fish, presents the blue dot, will result in a low bias of your results. As with the same detection efficiency, tagging a small number of fish will result in a bigger bias of your results. So it's always beneficial to tag as much fish as possible or realistic to gather unbiased data, even with a low antenna detection efficiency. The third variable of concern regarding efficiency, of course, is our antenna read range. Read range is something many people like to know before setting up their antenna system. Of course, this is not realistic. It's only fair to compare different tags or different antennas if you can do so in an RF room, so without any outside interference. The reason for this is that read range is affected by multiple factors itself. Let's have a look at these. So the first one is electromagnetic interference, referred to as noise many times. The type of tag and its orientation. And the third factor of influence is our entire antenna setup. All those things will affect antenna read range. So to begin with our noise, this is very important. thing to talk about and to consider. This noise, electromagnetic interference noise, can result from nearby power lines. You can have trouble with noise if you use an AC source to power up your system, which is quite noisy. So go for beds if you can. Also, electric engines or other nearby antenna arrays can induce noise. And noise will negatively affect your antenna read range. So it's very important, very, very important to check for noise before go for an installation. So it's the same when you're scanning, you're performing radio telemetry, you have to scan your frequencies as well to filter out certain frequencies that are not suited on that specific location. It's comparable to check for noise with a PIT antenna installation. Also, something quite important is that our antenna orientation can change the amount of noise that is received by the antenna. So if you put a pass-through antenna, so it's straight up, it could receive much more noise compared to if we would lay it down on the bottom in the pass-by orientation. So this can be a key issue to decide on the type of antenna you will deploy. Okay, the second thing that affects our read range of our antenna is, of course, our pit tag. Pit tag are we using? Most of the time, it reflects to the amount of copper within the tag. So bigger tags usually have a stronger signal, which of course results in a better read range. However, tag size is not the only measure to keep an eye on. Also, tag quality will determine your read range. I'll give you an example. Biomark's APT 12mm tag performs remarkably better compared with a same-sized HDX 12 tag. So both 12mm, same size, but a quality difference here. Besides the tag size and the quality of the tag, also its position relative to the antenna surface is very important. In pass-by orientated antennas, so this is the green. This is called pass-by, so lying flat on the bottom. Fish pass over, or pass by. The tag normally is in parallel position to the surface of the antenna. If our antenna is in pass-through orientation, which is the blue one, the tag is perpendicular to the antenna surface, and the read range of the same antenna in both orientations will be different for the same tag type. We have an example, just made a small graphic to show. So the green curve is the pass-by antenna, as you can see here, has a lower, is a read range, lower read range compared to the blue line, which is the pass-through antenna. Same antenna pipe, it's a 3-meter HDP antenna, same tag used, our APT12 high-performing tag. So this is the difference that just comes from tag orientation. If you look at the x-axis, you see that we calculated read ranges for different lengths of exciter cable. This brings us with our last point, one of the points that is of interest for our antenna setup. So the three different lengths, you can see clearly that the longer our exciter cable, I will say an exciter cable is the cable needed to power the antenna. So running from your reader enclosure to the antenna. So the longer the cable, the lower your read range of the antenna. However, Biomark has a solution for this by using a DOP style cable. This means a data over power cable, which can tackle this problem. As mentioned before, also nearby antennas can affect read range. So if you have nearby antennas, consider to space them or to multiplex them, meaning not to put them on together, like on, off, next to each other. Of course, other specs of antennas like the wire type that you use, The number of findings will also reflect on your read range. So far for theoretical introduction. Let's go on to the different antenna types and setups now. How to choose a certain type of deployment of a pit antenna? I would say look at your river first. Key points are depth and width, water velocity, and debris load. Some rivers can be highly dynamic with changing water levels, but other rivers can even be canalized, resulting in fixed water levels. So we have a lot of different river types. Even within the same river, you can have a lot of different locations. Before jumping into the water, there are some other criteria I want to stress before installing our antenna. So first of all, very important, like I mentioned before, we should do a noise measurement before any installation. This is very important to decide whether the location is suited or not. Also, safe access to the site is important for installation and data recovery if you're not working with remote communication. Regarding the power supply of your system, you have to ask whether you can profit from a nearby AC power source. If that's the case, it's really easy. Go. If that's not the case, you should consider to use solar, or if you have really low sunlight conditions, you can also consider a thermoelectric generator. Last point you have to think of before installing the antenna is how that you would like to retrieve your data. You can do it on site by using Bluetooth, cable, or even the flash drive device. Or you can choose for remote communication by cell or satellite with our biologic subscription, which offers a bunch of advantages, of course.
Rolf, there's a question about what do you do if your AC power is noisy, I guess, or if there's conducted EMI on the grid power.
Yeah, that's a good question. There will be some noise on the AC power. This is not a constant because it differs between several grids. Typically, what we do is we load our battery banks with AC power, and from there on, we have clean power to feed our devices.
Thanks.
No problem. Okay, we're ready to have a look at some antennas. So Biomark does a lot of different antenna types on a lot of different places. We can offer customized antenna solutions for almost any request. We do technical installations like processing plants, fishways, a lot of fishways, of course, hydropower plants, even laboratory facilities. We also do quite a number of terrestrial applications, like you see the penguin. We also had some applications for snakes, snails even, foxes, bats, a lot of interest for bats as well. But today we'll focus on our in-river systems. Back to the water, now technical installations. We make a division between three types of in-river antennas. First, we have a pass-by antenna at your left. So these are lying flat on the ground, most of the time slightly within the bedrock. Our fish and our tag are parallel to our antenna surface in this way. Secondly, we have the pass-through orientation types, in which the whole water section flows through the antenna field. And our tag now will be perpendicular to the antenna surface, which is theoretically at least more ideal compared to pass-by. But I will come back to this item later on. Thirdly, we have floating antennas as well, covering the upper water layer. These, in fact, can be considered as a reversed pass-by antenna. Let's start with the pass-by antenna types. We have different antenna types that we configure in the pass-by orientation. Typically, we should think on this type when rivers have an average depth of around 1 meter to have an acceptable read range. A great advantage of these types is that flooding and debris have no impact on these antennas. Also, like ice, wood that flows by, there's no single influence. Also, these antennas are less visual, and these are great for long-term monitoring purposes. Biomark offers 4 different pass-by antenna types that can help you out with your in-river project. Definitely our first type is the HDPE type, so high density polyethylene material antenna. These have been deployed for many years by Biomark now. We have those in standard lengths of 3, 4.5 and 6 meter. And these antennas have proven to be very consistent and durable, even when deployed in harsh conditions, like the northern of America, Canada. Normally, the reader, our IS-1001 reader, is housed near the antenna in a submersible node. A good thing to know is that our IS-1001 reader can read both full duplex and half duplex tags at the same time, if you want. So these antennas will pick up both types. So all Biomark antennas are equipped with this reader. So every Biomark antenna will read HDX, FDX tags. These antenna parts, let's name it, call it that way now, can be hooked up, resulting in a very long antenna array, over 100 meter if desired. But also on the other end, you can choose a small customized HDP antenna, like you can see on the left picture, which is in a small Swiss tributary. If you only have or need like 1 or 2 antenna, like in the middle, for instance, if you have a small section, these ones can be driven by only 1 reader for each antenna, but you can synchronize them if you need to know direction. If you have a more wide stretch, so if you have 3 or more antennas in your system, these antennas should be connected to the master controller. This is the device I show you in the middle of the slide now. This device can be placed even up to 300 meters away from the antenna array. And if you even need more than 12 antennas, we can sync multiple master controllers to support over 12 antennas. So it's as much as you like. You have to think this master controller, it's a device that acts as the command, the control, and the data collection center for the entire antenna system you're deploying. So you only need to ask one device or to send comments or to check your antenna, whatever you like to know about it. It's all there. If you decide to install such a system for the first time, I would recommend Biomark assistance, at least for the first time installation. Because this installation is quite technical, we have to anchor these HDPE pipes to the bedrock, and therefore we use these so-called duckbill anchors. So this duckbill will be drilled into the substrate. All the rest on top of it will follow down, and this comes over our antenna. It will be fixed with a screw on top. In an ideal world, this is done by a pneumatic drilling device, not by hand. This brings us with our second antenna type that we can use as a pass-by type. This is our Litz cord system. Litz cords are available in total antenna lengths of 9, 12, 18, and 24 meter. You only need to put an enclosure on the side to house your reader, together with any power option available. So batteries are preferred, of course. You can see that the cord as you see here, is divided in parts. It's not really divided, but its configuration is maintained by using rungs to have fixed distance between it to ensure that it keeps the same shape. Also, the anchoring is done by using a smaller duckbill anchor over here and attach it to the middle of the rung. So to keep everything down and stable, to have a good detection range.
Ralph, is the read range of, say, an APT12 tag, is that the same for all the different lengths of cord system antennas?
No, it isn't. As we saw with the exciter cable length, it's a little bit the same for the Litz cord. The longer the antenna, entire length, the smaller the read range. So the shortest one, the 9 meter, will perform better compared to the 24 meter. If people are interested in numbers, they can always check it, send us an email or call us. No problem. Okay, so now we proceed to the third type of pass-by antenna, which is quite special, I would say. This is our submersible antenna, which is completely autonomous. This is a real rigid antenna, and being autonomous meaning that it doesn't need a bank-based power option. So it has its own battery pack mounted on top of it. As you can see here, the white pack, it's all battery power going to the reader, which is here, and of course your antenna around it. We can offer these in 3 different sizes, a diameter of 0.9 meter, 1.5, and the biggest is 1.8 meter. You look at here. This one also is collapsible to facilitate transportation. These are really easy to deploy. So once you put your system on, you can put them wherever in the system you like, even in deep water. And you have to be aware that this, in fact, is more a qualitative approach. So we could call it like a presence-absence measure. It won't pick up every fish that swims in your system, of course, but it's quite spectacular, first results. Also, nice to mention, you can bait those for certain species of interest, and you can increase your, the attractiveness of your antenna and record more fish.
I don't know if you're going to get into this, but there's a question about how long the battery lasts.
That's a great question. We have 2 different sizes of battery packs. So the small one has an autonomy of 15 days, and the bigger one has an autonomy of 35 days.
Thanks, Ralph.
No problem. Okay. So here you can see another picture of our colleague Peter preparing the deployment of a batch of submersible antennas in a river that is not suited for other antenna types. Not quite sure, but I would say it's the Colorado River or a tributary of it. So it's a special antenna design. Last but not least, we have another pass-by antenna option, which is called the standard cord antenna. And this is really a great plug-and-play antenna. It makes very flexible use of it because you can just go out to the field, take the box. You can see on the picture, there's a box with the reader inside, a junction box, and then it's your antenna cord. Just get some batteries with you, and you're good to go. So that's really the most flexible antenna system you can imagine. It's ideal solution also for like temporary monitoring purposes. And a special thing about this is the tuning. The tuning of this antenna is done by modifying its shape. So there are a number of predefined shapes in which the antenna will tune very easy. But other shapes are also possible, of course. Then you have to do a little bit trial and error because it can require minor adaptations to the shape before it will tune. But in the end, it will tune. So once you have your batteries in the field, you can play around with it. It has a fixed loop length of 15 meters. So I want to stress the loop length. It's not antenna length. So the 50-meter loop will be like a 7-meter antenna length. And this is a, yeah, I personally, I really like this standard cord antenna.
Ralph, I've got a question from regarding the anchoring and maybe more of the traditional pass-by antennas. Where do you anchor when the bedrock isn't near the surface? And that might just be a little bit whatever language bedrock, what we consider bedrock versus boulders and cobble and sand and gravel substrate. So when the bedrock isn't near the surface.
So you mean when your underwater bottom is not very hard, when it's sandy?
Yeah, sandy or cobbly or bouldery.
Okay. I think the duckbills are performing great in between rocks and gravel. I was surprised of that first time I saw it, and I think it's the only way to be sure for a good anchoring. I would say if your soil is more like sandy or clay, you could choose other options, but I know these duckbills, you can anchor them from high height above the water, and you can drill them. You will drill them like 80 centimeters into the substrate. So whether it's rocky, whether it's gravel, whether it's clay, it has enough of depth into the substrate to be really strong.
Yeah,
And
I'll just add that we have done installations where we have anchored directly to bedrock or hard surfaces where the duckbill anchors won't drive in. And yeah, and in those applications, we actually drill a hole with a underwater hydraulic hammer drill, and then use traditional wedge anchors or lag screws to hold the antennas when in those applications, and it's worked well. And again, that's when that you have access to the bedrock, it's near the surface or at the surface, and you know that the duckbill anchors won't drive.
Okay, I didn't got the really rock question. Thanks, Steve. Okay, so this was the most flexible and simple last pass-by option, which brings us to our first pass-through antenna type, which again, okay, no, in general, I should say that you can use pass-through types for rivers up to 1.20 meters, maybe 1.50 of depth. But you have to keep in mind that despite the slightly better read range this antenna orientation has compared to the pass-by, the upper antenna part is vulnerable for accumulating floating material. So this is a point of interest, of course. A good thing if you have a river system with quite stable water levels, yeah, you can absolutely consider a pass-through antenna. And the things that are really practical are putting them close to culverts or road crossings because of the easy mounting options you have there. We can offer also our HDPE antenna as a pass-through antenna with the same standard lengths, but also with any desired customized length. The strength of these 10 centimeter tubes doesn't require additional cabling to keep the antenna in place. That's a really advantage of this type of pass-through antenna. As you can see on the pictures, they can be fixed with wooden poles, which are recommended to avoid metal interference. Yeah, great option. The second one is our lid cord again. Although it's not developed this way, the lid cord, it's really developed to be used as a pass-by option. These lid skirt antennas can be used in a pass-through orientation. Just have to consider that mounting these is a little bit more complicated, that you have to work with additional cabling, avoid metal parts. But it's feasible, of course. The thing that Biomark sometimes does is that we can pre-tune your lid skirt for a desired dimension in our facility in Boise. So once you're in place and you are deploying it, the reader will fine-tune it quite quickly and you're good to go. The third type of antennas we saw are the floating ones. So for some locations or for some specific fish species, this type of antenna can be beneficial. Especially rivers with fluctuating water levels are suited for this approach, as well as projects that focus on salmonid downstream migration, as salmon smolts are swimming high in the water column. These antennas can be combined with a bottom bypass antenna, as mentioned before, so that you cover more water column. In that case, beware to keep enough distance to avoid influencing each other and putting in interference to the other antenna. We have two types of floatables, of floating antennas. We have the inflatable antenna on the left-hand picture, and it's not the blue one, it's the green one. The blue one is another one. It's another just floating thing to keep the enclosure with the reader, with the batteries, and with the GPS. The green one is the inflatable antenna, and this one is developed for really short-term use. You should think of using it like for noise measurements. It's really great. You can just inflate it and you're measuring. You can put it in the backpack, so that's really nice. Or you can also use it on raft surveys. The other type of floating antenna on the right side is the more rigid HDPE antenna that is mounted on top of a fiberglass skid plate, just for stable deployment of the antenna. So some other pictures of the floating antennas, with on the left the raft with the antenna underneath, and on the right it's an example of the long-term monitoring installation with HDPE antennas mounted on the skid plates. Quite rough river.
Rolf, there's a question on the inflatable antenna. Are there multiple sizes of inflatable antennas?
I'm not sure. I think they are. Do you know, Steve?
There's only one size. It's a
It's one
3
size.
meter. Yeah.
Okay, it's 3 meter.
Sorry, 3 meter.
Because okay, go ahead.
And then what about the fixed or the rigid floating antenna? Does that come in more than one width or length at 3 meter? You want me to answer that as well?
Yeah, I could guess 3 meter is the fixed one, but I should say
we've done 3 meter or the 10-foot antenna is our standard fixed, and we have done some. We just did 15-foot or 15-foot antenna, but it gets for a spillway, but that larger width becomes somewhat unwieldy and heavy. So I would say and I've been told not to ever sell that again. So the 3 meter fixed antenna and the 3 meter inflatable antenna are the only sizes of the inflatable antennas that we offer.
Yeah, great. Okay, Steve, thank you. All right. So now we've gone through our in-river antenna range, which you can see in a schematic way in here. So we had 4 different pass-by types: HDPE, lid cord, our submersibles, and the flexible standard cord. For the pass-through orientation, we again offer the HDPE and the lid cord. And for the floating, we just saw the rigid and the inflatable one. Of course, Biomark can also offers other types of antennas, like handheld antennas. The the handheld, like a metal detector type, or shielded antennas are possible in places where there is really too much of electromagnetic interference. We can provide a shield to prevent it from, to cover it for this interference. We also offer low profile antennas, all of which you can find on our website. And as a conclusion, I would love to give you some key takeaways. Probably the most important message today is to optimize your detection efficiency, which you can by optimizing the read range, by tagging as many fish as possible, and by using the best antenna setup for your project. Remember that the Biomark IS1001 reader is the only high-performance auto-tuning reader that is specially developed to monitor PID tags in fish. It will read both HDX as FDX tags, which is a unique quality. Finally, be aware that we are very happy to help you with any request or question. Therefore, you can call us, email us, or visit our website. So thank you all for attending this webinar.
Okay. Ralph, I have a series of questions tonight. Thank you very much. I have a series of questions that are coming in just throughout, topics throughout your presentation. So you showed if my antenna sticks out of the water, there was a large channel spanning HDP pass-by antennas that you showed, and part of the antenna was out of the water. How does the performance change, or how does the reader deal with, it's sometimes a year it's underwater, and other times of year it's dry?
Yeah,
is that an issue?
That's a good question. That's something I was wondering myself, because this is really a good example of changing environmental factors, that can detune your antenna probably, but we have noticed that it's not affecting anything about read range, and that the IS1001 can correct perfectly for these conditions. So there have been a lot of deployments in harsh environment when indeed parts of the antenna were not submerged, and even in minus degree temperatures, but antenna performance was perfect.
That's fine. Okay. Yeah, I think there's that system in Iceland and the Arctic Circle they've performed well. And I guess I know one of the pictures you had of the pass-through antennas was in an estuary near Seattle, Washington. How does the antenna performance change as tides come in and tides go out, and the water goes from a freshwater or no salinity to more of a brackish? Does that impact the antenna or the antenna current?
Yeah, it definitely will have an impact, but as long as the units are not you're not really salt seawater, then when it stays within the capacitor board range of your antenna, it can correct for salinity continuously.
Okay. And then let's see, there's another question. So, and I think you said it, but just to reiterate, how far can the master controller be from the antenna array?
At least 300 meters, but yeah, could be further away. Yes.
1,000. Okay, 1,000 feet.
1,000 feet.
And then for the LITS cords, that looks like a cool antenna. Can I put those across the river? Can I deploy multiple LITS cords to sample the river instead of using multiple pipe antennas?
That's not too easy. When you're using a LITS cord in a pass-by or a pass-through, that's different. I think in a pass-by, you cannot compare them. So every LITS has its own reader. And only in the pass-through orientation, I think you can synchronize them. But Steve, correct me if I'm wrong.
Okay, no, that's right. So I think I know that for the Litz cord in a pass-by orientation, they have to be treated as standalone. They can't be synchronized or multiplexed due to the amount of energy. Since the entire antenna is down on the ground, you're pushing a tremendous amount of energy into the ground, and if you connect the two antennas, whether it's through a communication cable or a ground wire, they interact and the antennas don't perform well, which is different than what Rolf said, where you can put two Litz cord antennas in pass-through orientation, and then, as the photo showed, it's a typical synchronized IS-1001s where you can have two IS-1001s in an enclosure in a job box, and then have your, 20-meter exciter cables extend to each antenna, and that makes a really efficient deployment for monitoring rivers up to 6 or 7 or 8 meters wide. I've got a couple. So where on the Biomark website do we find the recorded series? Again, it's in the news. Elsa, could you send me the reply to that, and I'll pass that along. And now from Ben. Hello, Ben. Yeah, so Ben's question. Ben is a statistician for NOAA Fisheries in Seattle. Said, you noted the more tags, the better for efficiency, but do those tags need to be spread spatially, across an antenna or temporarily in time to avoid tag collision, which would negatively affect efficiency?
No, that's a great question as well. Yeah, the best assumption is to have them spread out to be homogeneous spread. It's also the same assumption that you need when you're measuring for efficiency with multiple antennas. But coming back to this collision issue, it could appear, but be aware that if you use like full duplex tags, this is far less an issue compared by using a half duplex tag, which will be influenced a lot more by tag collision when schooling activities or grouping fish together near an antenna appears. So I don't know if this can give you some answer, or if Steve can add something to this.
Yeah, no, it's tag collision can always be an issue, and that's where I guess I look at these large Litz antennas that we can make that are, whatever, 40 feet wide, and that's a great antenna, but now you have a single antenna, so you could have a tag, on opposite sides of the river, and if their tag signal is the same amplitude, they will collide with each other, and you may not detect either tag. You can assume that through time they kind of change orientation, and so the amplitude of one tag signal is then higher, and so it's detected. That compared to some of the large antenna arrays we've done, where they're, that the channel could be 30 meters wide, and maybe you can build a 30-meter antenna, but tag collision is a concern. So you break that up into a series of 6-meter antennas to give you, greater resolution, some redundancy in case something were to fail, and also helps address tag collision. We see tag collision in river locations mostly with releases of juvenile fish, where someone will or a group will release whatever 50,000 pit tagged fish out of a transport truck at the same time, and invariably that results in tag collision, or it can.
Yeah.
Here's the so Elsa posted, who's the ringleader of all these webinars. She posted the link to where the seminar or the webinar videos can be found. Let me see. I think let me go back over to here. So let's chords. When deploying a floating antenna system, how does the antenna compensate for rising and falling water? Is there
Yeah,
Is this
it's the same. I would say whether it would be at the bottom if your water level changes, you know, uh, numbers will change and your reader will have to adapt, retune, auto tune it to because it can be detuned a little bit from changing environment, but it's exactly the same with the floating antenna, I would say.
yeah, okay. Yeah, and I think this was more um, the picture you had of the floating antenna in the spillway, and um, I guess that's a system that I was part of in Washington at Zozel Dam, and it had um, a rigging system that allowed the antenna to go up and down with the water level.
Yep. Oh, it's a
That's
guidance system, yes.
yeah, yeah, that's the intent at least. Um, okay, one more. There's another question. If I already have a system and want to add more antennas, how easy is that to do? I guess I'm assuming this would be an in-stream location or a pass. Well, either pass by or pass through. Maybe you didn't have budget to put in multiple antennas the first year. Can you come back later on and add antennas to an array?
Yeah, sure, that's no problem. Uh, if you're planning in this way, if you're thinking about putting one and maybe if budget allows later on to add more, then you could think of initially putting a bigger enclosure that can house multiple
Mm,
readers or even a master controller when you're over two systems or two antenna, uh, more than two antennas. So that's perfectly, that's no problem. We have some systems in the UK. Uh, it was the same. So they started up with one antenna. They added some more, and the second time they added a master controller because they went more than two antennas, and they now still have room for like four or five more antennas to accommodate with those enclosure.
okay. Um, what about remote monitoring? You mentioned early in the presentation you had data collection, data retrieval, and cell phone. Where does that go, or what is that all about?
Yeah, that's a good question because I didn't went into it. And in fact, I like it because you can go for a biologic subscription by using remote control. So your data basically are sent by modem or by satellite to our host facility in the States. And they're accessible for you in near real time, meaning every 4 hours they will get refreshed. And you cannot only retrieve your data because for me, the most valuable thing about this is that you can continuously check the performance of your system. You can set a number of alerts about your antenna current, your voltage, or you can even set like, okay, if this range of tags are passing, I want to know it. Just
Mhm.
send me an email or whatever, and I want to know it because then, for instance, silver eel run starts, or we have to call to hydropower operator. So these things are really great. So and also the just to check the performance of your system all the time, which can allow you to prove afterward. Let's assume you have a 2 week period without any detection, then you can afterwards prove like, okay, but my system, I have the data, it was performing perfect. So it's 100% 2 weeks, no fish that passed. So that's really available to have really robust data. And that's the thing I like about it.
Yeah, so you can look at the diagnostic data from the IS-1001 reader, the antenna current, the
Yep,
FDXB noise, and determine that the antenna system has performed consistently. There just weren't any tags passing during that period of time.
correct.
Yeah, versus having your antenna, the reader system fail for a week or a month and not
Yeah,
really know if that's the case.
yeah. And of course, it's an extra cost, but you have to compare by going out there and check it, even not knowing whether it's performing well or not. So yeah, it's about data quality for me as a biologist.
Okay. Okay. I think that's all of the questions other than what Jake keeps asking. So we can, looks like we're at time. If we want, we'll hang out here for a couple more minutes, but want to thank Rolf and thank everybody for attending. If you have any additional questions, please feel free to contact anybody at Biomark, Rolf, Armando, Jake, Gabe, Elsa, Matt, Roman, and we'd be happy to answer those questions. So thank you very much, and we'll hang out here for a little bit and go back to work.
Thanks, Steve.